Hmm. Yep, you should be able to request it, and then I can grant you access.
Yeah, okay.
This
The
meeting is being recorded.
Perfect. All right. Says a disabled chair, so I don't know if
Oh,
that's something you would do on your end or not.
let me see. There we go. Now it should be good.
Perfect. Okay, there you go. All right. So what I'm trying to build is a um ultrasonic speaker, but I think you might know it better as like a sound laser. So it would basically use like these ultrasonic transistors. And let's see. I'm trying to make it powered by an Arduino so it can be programmable.
Hmm.
Hmm. Let's see. I don't know what engineering discipline are you in, Jonah?
I'm in mechanical engineering, so I've done like I have a few like EE computer engineering kind of classes. So like I have know what you're talking about. It's
Yeah.
not like my exact area of expertise, but like I should still be able to help.
Any help really I really appreciate it. Yeah.
Yeah, for sure.
Yeah. So this is just like a design I found from a YouTube video that basically did the same thing, right? Of course, I'm gonna add like a specific shell because I think if we can just manipulate the direction of sound from the outside, I think they could amplify what's already here mechanically. So let me just show you a picture of the back of this board. Hang on. Yeah. So so I'm not much of an engineer, I'll be honest, but I am a physicist, so I am familiar with a lot of the principles here, like like
Hmm.
this a resistor, capacitors right here.
Yeah.
All right. So let's see. How would you recommend I get started, since you're more experienced than me?
Okay. So what is your goal? What are you trying? So you want to build a sound laser. What do you want to, what do you want to use it for?
Mhm. I'm mainly trying to see if I can use it commercially, either
Mhm.
say in a car or for those Meta glasses, right?
Yeah.
They use regular speakers on the hinges, and if you're close enough, someone can still hear it. So we could use like condensed versions of this for that. So it's
Mhm.
truly monodirectional,
Okay, so it's like a monodirectional speaker, basically.
basically.
Okay, sounds cool. And yeah, the thing you showed me, so all those things are just like little speakers that project in one direction.
Yeah.
The first
Mhm.
image, if you want to pull that up again.
Oh, yeah, sure. I got you. Do, do, do. Mhm. Let me
All
actually
right.
send the PNGs to the chat. Hang on. Wait. See chat. Gallery. Open. See, there's that one, and here's a good shot of the back.
Cool. Thank you.
Mhm. Yeah. So I know they got what I think is called the breadboard. Is that what it's called? Where you put all the components in?
Yeah, it's a red
Breadboard.
one.
Yeah, breadboard. I see a resistor here, and I'm going to assuming. Um, let's see. Let me take a closer look at
I'm
the.
guessing that big blue one's a capacitor. No, wait, the
Yeah,
one next to it's a capacitor, definitely.
yeah, hmm
That could be a capacitor, it could be a.
yeah. hmm
Mm.
All right. Let's see. So I am
I
planning on sending this in as like additional information when I get like my new test score and everything.
Hmm.
For
What do you mean your new
colleges.
test
So
score?
oh,
Oh,
from the ACT I just took.
okay.
Yeah. So
That's a
I'm
good idea.
planning sending in with that. Mhm. So I'm just seeing, should I build a schematic first, or should I just go straight into trying to build it?
No, I would definitely build a schematic first
Hmm
before you even start making a prototype. This also looks like it has, you see the black stuff?
Yeah.
Like
Or
the long
the
black rectangles? Those look
yeah.
like microchips.
hmm
So you're also gonna have to
Yeah.
be playing with microchips.
What
I'm
I
trying to
was
figure out
thinking is
those
that we
things.
could work with something programmable like a Raspberry Pi or an Arduino Nano.
Instead of the
Yeah.
microchips.
So that would basically act like the CPU for this project. So we could make it programmable, and we don't really have to worry about playing with a lot of electrical stuff on sound.
Okay, that could work. How much
Mhm.
experience do you have playing with electronic things?
Hmm. Let's see. For the most part, I've had like a small elec like starter kit a couple years back. I've also been exposed to it through Boy Scouts, learning how to um connect radios to like automobiles.
Okay,
Yeah.
sounds good. Um, right. So I think to start, you need to work out like exactly what your plan should be.
Hmm.
So if I were you, what I would do is I would start with like research, so we can research together, and then by researching, we can put together a list, like a basic plan of like how we're gonna assemble this thing. So obviously, like circuit diagram, figuring out like how you're gonna wire everything,
Hmm.
um, list of components that you're gonna need, and then yeah, honestly, like the ease, just like start building.
Hmm.
Like you learn the most by like messing around and playing with things. Like I have, wait, let me hold on, give me a second. Let me see if I still have
Yeah.
my kit. Don't move. All right.
Hmm.
Let's see what we have in here. Speaker. Okay, so like I got this kit that I got from like one of my classes. I have like a bunch of microchips,
Hmm.
like some breadboards, Raspberry Pi. Let me see if I have a speaker that I do. But yeah, that's how I would start. So I would start. Do you have any of this stuff or no with you?
Hmm. No, but I did make like a good list
Okay.
about potential stuff we would need. Like for speakers, I found some a really cheap source to get them. Apparently, Walmart has a good bunch of them. Yeah, let me see if I can find them again.
Yeah, I'll also look on my end.
Yeah.
Send the link if you find it. I'll
Of
look too.
course. Yep. Wait. Hmm.
What do you want to be able to program with the Arduino? Like, do you want to be able to modulate like how loud the sound is? Or do you just want to be
Yeah.
able to like turn it on and off, or like what else do you want it to be able to do?
I'd like it to be able to play some kind of music. So, they would see like the commercial application for it. Mhm.
Okay.
Yeah, because apparently I heard that it's this really cool effect where the sound feels like it's coming straight from your ear canal. Mm.
Ah,
Yeah.
that would be pretty cool.
Yeah. So I don't know if you've ever listened to Tame Impala,
Yeah.
if you know. Okay, so you listen to
Yeah,
Tame
yeah.
Impala? I've like how his music is very, very trippy, right? Especially when you have headphones.
Mm-hmm.
I really want to hear it from a mono direction. See how it feels like when
Mm,
that music's inside your head.
that would be interesting. I agree.
Yeah.
Okay, cool.
Let's see here.
Um,
Let's see. Yeah, I just pulled up the ChatGPT page I found it in.
okay.
Yeah. Ideas. Speak. Mhm. Let's build. But yeah. So are
Can you
you
send me?
hmm? Are you familiar
I was
with
gonna,
yeah, go ahead.
I was gonna say, can you just send me the list of components you have so far?
Yeah, yeah.
So I think we
Like
can
on
work
me
on
or
that.
it's just the ones that I found?
Just the ones of like the entire list of stuff you would need. So like, yeah,
Mhm.
not just the ones you have on you, just like anything you think you'll need, and then we'll see if there's anything else I would
Yeah.
recommend.
Let's see here. Certificate. Mhm. And, let's see here. Is this here?
You got the Arduino Uno, good.
Yeah. Mhm.
See if I can find it.
Mhm.
It's like a kit. Yeah, it's a kit.
Yeah,
So it comes with
basically, yeah, it's
stuff.
a kit.
Okay. And then that's good. I'm guessing you can plug this one into your computer, right? And the computer acts as the power source.
Hmm.
Okay.
Yeah. Of
Cool.
course,
So you have a power supply.
yeah.
Yeah.
Of course, I may want to buy like its own separate power supply.
hmm Yeah, I'm not sure how much power it would need.
Hmm.
Mm.
Let's see here. Oh.
Have you thought about which speakers you're gonna get?
Yeah. Like I found this one specific kind of speaker, having trouble
hmm
finding it again. So just bear with me for a second. There, this might be it. Ah, here it is. Yeah. These are basically two of very similar components. Actually, three. Yeah, I found three options.
Okay. Yeah, this looks good.
Mhm. All of them
I
look
would.
pretty much the same. The only difference I think would be price. They should all be the same hertz, which is important here because I don't want to short circuit anything.
hmm
Yeah. So, drive transducer.
Yeah, I would definitely buy off a DigiKey.
Did you keep?
Yeah, DigiKey or Amazon.
Mm-hmm.
Okay, yeah, that
All
looks
right.
good.
Mhm. Let's see. As for the breadboard, like there are some cheap options I can just find on Amazon.
Yeah, literally just buy the cheapest one. Like it doesn't matter. Does the Arduino kit not come with one?
Arduino kit. It should come with one now that I think about it. Hang on. Let me just check. Because I'm probably going to order it from the Arduino website. Let's see. Let me check.
I mean, just see what it comes with. Maybe not actually. Maybe it's just a. I don't think so actually. It's just the like chip,
Yeah.
just the microcontroller. Never mind. But yes, you need a
Mhm.
separate breadboard.
Separate breadboard and like my own wires and stuff, right?
Yeah, you should look for like a kit that will come with breadboard,
Hmm.
wires, resistors, capacitors, um, like wire strippers.
Yeah. Okay.
I think that's all the basic components that you'll need.
Let's see. So,
Uh,
so I know I need to. Would I only need to build like the circuit diagram, or do I also need like something like a CAD model?
no, you definitely don't need a CAD model. You just need a circuit diagram. That's
Mhm.
enough.
Okay.
So let's
Yeah.
look
So
up circuit diagram.
circuit
Speaker.
diagram.
Okie dokie. What do we need for a speaker? Have you ever looked at circuit diagrams?
Yeah. I'm familiar with them from AP Physics C. So,
Okay.
mhm. I think speaker,
All right.
sir.
Are you still sharing your screen?
No.
All right.
So let's see. Mhm. Okay. So
Let's see what we need. So
jack.
these all look like these use op amps. Hmm.
Mm-hmm. Here. see. It seems like they most of them use some kind of capacitor here, or at least the one I'm looking at is using three capacitors with a positive and then a negative side.
You want to
Oh,
share your screen?
yeah, yeah, I got it. Let's see here. Yeah, let's see here. Right here. Hmm. So you see here it has like has a headphone jack,
Hmm.
and from what I remember, and let's see if I can zoom in. Yeah, it's the image here. These three bars mean ground,
Yeah.
right? Yeah, yeah, this is ground, and this is where the circuit is overlapping with itself.
Hmm.
So let's see. Here's a resistor, um, capacitor. I forget what the double bars mean.
Double bars capacitor.
Okay, there's also a capacitor. Oh, but two positive sides. Okay, positive, negative side. Is this a microchip or a battery?
Yeah, that's an op amp. It's a type of microchip, and
Hmm.
that's what you're gonna need to be able to like send waves to like play different like frequencies. So if you want to like play music, you're definitely gonna need op amps. And then
Hmm.
yeah, I would recommend like watching a YouTube video about op amps and how they work. And
Op
then you
amps.
yeah, OP AMP. It's
Okay.
operational amplifier. You can also look at the data sheet and like
Hmm.
here, look up op amp
See here.
like in a new tab, just pull up op amps
Yeah.
because these will be important to understand how these work. Yeah, op amp
Mm.
like maybe diagram.
Yeah.
Okay, look up op amp data sheet actually.
Beta sheet?
Yeah, data sheet.
Data sheet. Okay.
And if you go into images,
Mhm.
hopefully. Yeah, that one. Okay, so the one next to the one you're on right now.
This one?
No, sorry, to the left.
Okay, my bad.
Yeah, so like this is how an op amp works. So basically it has like eight legs, eight pins, which you're gonna plug into your breadboard.
Okay.
And then
Yeah.
they all do different things. So like you need to connect one to positive power, one to ground. And then
Mhm.
the important ones are two, three, five, and no, two, three, six are the ones that actually do things that will like allow
Mhm.
you to program your circuit. So yeah, you
Yeah.
should definitely like watch a video about op amps and get more familiar with op amps.
Okay.
Because you're 100% going to need those in order to like
Mm.
modulate your circuit. Because if not, you're just going to be like playing one sound. Um,
Mhm. Okay. So op amps.
yeah, so I'd
Let's
definitely
see.
buy an op amp.
Yeah. But okay. I have to familiarize with myself because I'm assuming these come in different voltages and outputs, right? And they all kind of have to match with each other.
No, this should you should just I mean yeah they do, but like you should be fine just buying like the standard one. Like the standard one is
Okay.
just like plus 5 volts.
Plus 5 volts. Okay. Hmm.
Just like whatever the first one. Wait, let me look op amp.
Yeah.
Let me see what they have on shopping. Yeah, they're like $10, not even like $5,
Hmm. Yeah.
depending where you buy them from. If you get them
Mhm.
from a reputable source or not.
Yeah. I'll probably buy from some kind of electronics store or website.
Yeah.
Hmm. Let's see
So
here.
yeah, getting familiar with op amps is going to be important. So you
See.
need op amp, wires, capacitors. You got your speaker. You got your Arduino kit.
Hmm. Let's see.
Let me see if
Oh,
I can
right.
find a good YouTube video.
When they say ground, right? Like in the circuit diagram, when they're saying that's connected to their ground, where do you think that would be? Would any kind of metal work, or does it have to be
No, no,
non-conductor?
no. Pull up. Are you still sharing your screen? Or I can
Not
share
yet.
my screen.
Yeah.
Right, pull it up. We'll just you can do it. Um, share your screen and look up a breadboard.
Mhm.
There. So you'll see this like a if you go to images, look up breadboard and go into images.
Yeah.
So oh yeah, like okay, look at any of them. You see there's a blue line and a red line.
Yeah.
So the blue line is ground and the red line is power.
Okay.
So when you're grounding it, you plug it into the blue rail. And
Mhm.
when you want to give something power, you start at the plus five, like the red rails.
Okay. So blue is ground, red is power.
Yes.
Cool. Ground, red, cool. Power. Okay, nice.
Yeah, and then once you get your Arduinos, you like plug your Arduino into the top, like the middle
Mhm.
bit at the top, and then you'll plug into your computer, and that's what like powers the +5 rail.
Mhm. Okay, how would I represent the Arduino in the circuit diagram then? Would I have to map out the entirety of it, or?
Um, I don't think you usually do.
Mhm.
Let me check, but I'm pretty sure you don't. It just
Okay.
exists as a separate entity,
Okay,
or
kind of like
you just put it as a black box.
oh, black box.
I believe so. Let me check.
Yeah, because you worked with a
Yeah,
Raspberry Pi before, right?
yeah,
They're
yeah.
similar enough.
It's just like any other chip. So like it's just like a rectangle, and
Uh-huh.
then you like link the wires in. And like if you really want to get picky, then you write out the numbers of the pins.
hmm Is that something I should be doing or not?
No, I
Like,
think for this it's fine.
yeah,
Wait, let me
okay.
see if I have. Hold on. Go back to my box. Okay. Well, that's not as useful as I thought it was gonna be. Mine. I just have random bits of paper. Yeah. Okay. So this is a Raspberry Pi, but it's
Mhm.
the same idea for an Arduino. Um, when you get it, you'll get like one of these, hopefully. And this shows you like what all the different pins do. So like when you plug it in, you look at the data sheet and you see what you want to do depending on like what pin. So like it has ground pins, it has like power, just like power. So if you plug it into the power, that will just like supply a constant 5 volts to your circuit. If you
Mhm.
plug it into like, let me see, GPIO, PIO, or PWM, that allows you to like control how much power it's getting. And then there's like a couple of other set two things. So like you don't need to draw this in your circuit diagram, but you should have this by you so that you know what each pin of your Arduino
Okay,
does.
all right. That's handy at least.
I'm pretty sure I had a speaker somewhere.
Mhm.
We can low-key start like just messing around with wires. I have all these circuits made. I don't know what they do.
Mhm.
Um, but geez, I really wish I had a speaker. Oh, you should get one of these too. They're kind of fun. A potentiometer.
Potentiometer.
Uh,
Wait, heard of it. It's like an adjustable resistor, right?
yeah, exactly. So you can adjust how loud your sound comes out. Um,
Oh, okay.
they're kind of fun to play with.
Potentiometer. Let's see. What discipline would you really call this? Electrical engineering or like mechatronics?
Yeah, this is definitely electrical engineering.
Hmm
I think this is a speaker right here. So we
Yeah.
can plug it in and see if it works. Hmm. Okie dokie. But yeah, so actual recommendations, I would so I would get together like a full bill of materials, like an entire list of everything you're gonna need,
Mhm.
order all that stuff, and then while you're waiting for it to come, watch like YouTube videos of people building circuits,
Mhm.
and then like kind of build your way up. So like start with simple circuits. So like literally like just I plug a wire into +5 volts, slap it through a resistor into your speaker and like see if you can get it to play a sound. And then like build it up layer by layer. So like first just get like a constant sound, then like be able to turn it on and off with like a button, and then like be able to like change it with a potentiometer, and then like is Arduino is like it's you have to it's like you have to program it, right? It's like a Raspberry Pi.
Mhm. Yeah.
Okay. How good are you with programming?
I'm very strong in Python. An Arduino does is based off C++, I believe, but there is an extension to where you can translate into Python.
Okay.
Yeah,
That's
so you
good.
can use Python on it.
Yeah, you can also definitely find a bunch of open source stuff. So
Mhm.
my guess is you wouldn't, if you don't want to, you don't have to write anything yourself. Like if you want to, by all means, go ahead. But like if you don't feel like it, I'm sure you can find um open source code online,
Yeah, especially
which
on
will
GitHub.
allow you to, yeah, for sure.
Mhm.
Which will allow you, or ChatGPT is really good at coding,
Mhm.
and
Yeah.
it will allow you to like input code to like play different sounds or whatever. Because yeah, if it's like I think with a Raspberry Pi, I'm sure it works the same. You can like tell it to play a certain frequency, and it'll play like
Uh-huh.
a certain frequency.
Yeah.
Um, and then you could like make a pattern like that.
Okay. So does that basically bypass a potentiometer or
Yeah, it removes the need for a potentiometer.
okay. Because it's
Um,
just programmable. All right.
Yeah.
Yeah.
Potentiometer is like a manual program,
Hmm.
like if that makes sense. It's like a code, a manual code.
Yeah. Okay.
Um, yeah, so that's how I would start. I would start by just like messing around, getting more familiar with it, and then once that's done,
Hmm.
what? Well, I mean, what do you want to? What's like your goal? Are you trying to like build like a prototype? Are you trying to like build a final model? Are you trying to like make a pitch, like to talk about
Yeah.
it to whatever people,
Yeah. So
investors?
I guess we can start off with making a prototype. After
Okay.
that, we can, after we just make like a base prototype, we can then start going into potential casings for it to amplify the sound, to make it like truly mono-directional. Because of course it's going to bounce off the walls in the room. Can't really help that. But I
Uh-huh.
think whatever, depending on the kind of caser we put around it, it could definitely help out with making it, you know, just a beam of sound.
Oh, that's true. Yeah, I forgot that's the main objective is to make it a beam. Okay, yes.
Yeah.
So the once you have a prototype and you can basically like make sound, whatever, the next
Mhm.
question is turning it into a beam. So how do you what are your ideas for turning it into a beam?
Well, the speakers themselves are already at a high enough frequency where they're pretty straight. But unless you're outside, you could, yeah, unless you're outside, you can basically still lightly hear it. So what I'm thinking about, since well, sound is a wave and waves can bounce off of surfaces,
Uh,
if we can make a specific shape that can direct it a certain way, we can make it as close as to like a sound laser as possible. Yeah,
okay. Is
yeah.
that how the speaker already works? Like how does the sound laser speaker work by default, like initially? Is it like
Mhm.
being channel is the wave being like sent in a specific direction or how does it work? Do you know?
It is basically being set in a specific direction. It's gonna be easier if I can draw it out. Hang on, let's see if we can have the whiteboard up.
Yeah.
Yeah, yeah. Whiteboard. See here, new whiteboard.
Hmm.
Mhm. All right, perfect, perfect. So this is a prototype right here.
Yep.
So in the way that normal sound works, it's omnidirectional, in which case the source travels through the medium in all directions.
Yep.
Yeah. However, with these transistors, these ultrasonic transistors, though the waves from the audio are condensed enough to where they only follow a straight-ish path. Mhm.
Hmm.
So let's say if you're in an open area, like outside, you would basically only hear the the audio if you're in the range. However, that range does increase the the farther you are. So say this is person A, they would hear it pretty straight. However, at this distance, the wave would grow a little bit, so person C would be able to hear it instead of just person B. Hmm. However, with the right casing, we can just make the the area of effect smaller and smaller, so that it's not too noticeable from where person A hears it and where person B hears it.
Okay.
Yeah.
I see the vision.
Okay. You see the vision. All right.
Um, so the way it's working is it's a really high frequency, right?
Mhm. Yeah.
How presumably beyond the uh audible range. So how do you make
Mhm.
it audible again? Like how does it become audible?
Oh, it's this really cool physics trick. So let's see here. Let me erase this. So most of the sound we hear is acoustic sound,
Hmm.
which is I forget the exact frequency, but it's within a couple of hertz. Mhm. If we condense it even further, we basically just condense the amplitude of the wave. So it would go from right here to basically like this. And that would be ultrasonic or beyond the human ear.
Hmm.
However, just like FM radio, the way FM radio works is that it carries acoustic sound through condensed radio waves. And you can do the same with ultrasonic waves as well, carry sound through them, which is what a most mono speakers do. There's this
Yeah.
really cool YouTube video. I'll actually send you the YouTube video where I got the inspiration for this from. Let's see here.
Yeah.
Yeah. Explains it in a better way than I do. So feel free to watch that on your own time.
For sure.
Turning sound into a laser. Yeah. So it's basically just off the principle of how light works as well. You know how light is a wave, right?
Hmm.
hmm And you can just condense that wave into a laser. Basically, this guy had the idea that you can do the same thing with sound. Mhm. And then a
That's
couple other
pretty neat.
people, yeah. So a couple other people started doing their own projects based off of this. So I'm trying to take it one step further from just the concept itself into what kind of
An
casing,
application.
yeah, what kind of applications could I have commercially? Because there are commercial speakers, right? Like commercial mono-directional speakers, but they're usually kind of treated like JBL speakers, where it basically just becomes a regular speaker instead of like truly a beam of sound. Yeah. And like I said, you
Yep.
can use this on like smart glasses to where it can be just, I know it's a pretty shitty drawing, but like bear with me. Just you who hears the audio instead of the people around you. It gives a new sense of privacy. And that's how I think this can be applied commercially.
Yeah, I agree. I think it's a good idea.
hmm
Um, me
hmm
and so he has a circuit diagram at some point. And what else does he have? Okay, so I don't know if you want to build it in the same way he did. It could be an interesting idea.
hmm
Like if you have the video open, it's like at the 1 minute 30 timestamp.
Yeah. Let's do 1 minute 30. Oh, my bad. I got like a bunch of tabs here. There you go. Minute 30, right?
Hmm.
Yeah. This is his circuit diagram, correct?
Yeah.
hmm
So you might want to get some of the components he has.
Let's see.
So
A 12-volt
specific,
battery, right? Let's
yeah.
see.
So most of the stuff is pretty straightforward, and you should get from like your kits, like the 12-volt battery. That's fine.
hmm
The 2K resistor, the 100K resistor, the 160 picofarad capacitor, all that's
hmm
okay. And then he's using 3 chips is the important thing. So he has a
Yeah.
NE555, which is a 555 timer.
hmm
So I would get one of those. I would get I'm not exactly sure what the L293DNE is. Let's see, L293DNE.
hmm Let's see.
So
What I am wondering, however, is since we're doing something unique using Arduino to make it like programmable and stuff, would the Arduino just replace all three of these chips?
um, I don't think so. I think you still need the chips, and the Arduino works with the chips. Let me look up what these chips are specifically before
Yeah. Understood.
you confirm that. But let me flick through the data sheets of the chips. Mm-mm-mm. Yeah, in the meantime, while I'm taking a look through these,
Mm-hmm.
I'm trying to think what like good next steps are.
See.
Yeah, I would. No, you don't have an Arduino right now. Yeah, I would. I think a good order of steps is like you get stuff, you start messing around with the stuff, messing around with the Arduino, um, and in the meantime, you like work on specifically the commercial application. So like
Mm-hmm.
you do it in the form of like, okay, so a problem, what is a current problem that exists in the market? Why is this a problem? How is this a problem? Why is it not being fixed yet?
Mm-hmm.
Then you look at either what other people have attempted to do to remediate this and why they failed. And then you say, this is my solution. This is how it works. And make sure that like you're clearly able to like explain how it works. So that even someone who like knows nothing about electronics could understand it and follow. Obviously
Mm-hmm.
don't dumb it down completely, but like so that they could follow. And then yeah, so like kind of make like a pitch for your thing. So like I don't know, just like pull up a Google Doc. It doesn't have to be very long. Just like it can even be bullet points, but
Yeah.
just so that you have like kind of a pitch going. While I look at these microcontrollers.
Let's see here. Pitch. All right. Let's see. I have the Google Doc pulled up. Let's see here. A. Let's see. Mono. Rec. All right, so I'll just start off by calling it a monodirectional sound emitter. Straightforward enough.
Hmm.
Let's see, sound emitter. Um, so let's see, what makes it different from the rest? Well, it's programmable because we're using an Arduino.
Hmm.
Yeah, so programmable. It's programmable. Let's see, I guess we can start out by making it compact. Yeah, we can make it compact because like an Arduino is small enough, and if we're trying to put this in like a smart glasses, so we can just put compact for now. Compact. Compact. Let's see. What else would you recommend for a pitch?
What do you mean? What else would I recommend?
Oh, just to like put on this document.
So yeah, I would say like current problems in the market,
Yeah.
like what's missing, and then why like other things that people have tried and why they haven't worked, and then why your thing
Hmm. Um,
A solves a problem in the market and B is better than other things slash works better than other things slash creates a new thing. Because I feel like in
okay.
your case, like there's not that much stuff that exists that does what you
Mm,
want to do.
yeah. So we can put that as a plus. Like
Hmm.
current problems in the market, there's not much of a market.
Yeah.
Mm-hmm. May sucks. Why my thing? Okay. Yeah. So let's see. Monodirectional sound emitter, programmable, compact. Mm-hmm. Competitors and why they suck. Why my thing is better. Okay. Have you finished going through the video yet? Right?
Uh-huh. Yeah.
Mm-hmm.
So let's see. Yeah. Okay. So you don't need the 5 5 timer. So the Arduino replaces that.
The NE555, right?
Yeah. You don't need that. But you still will need like some form of L293D because
Mm-hmm.
this is a driver
Okay. What does the driver do exactly?
and let's see. Yeah, so the driver I think it basically adds voltage. So like the Arduino is only 5 volts, and this
Mm-hmm.
needs like a higher voltage and current than the simple GPIO of the Arduino could supply. So like basically
Okay.
what this chip does is it boosts the voltage from I
Okay.
think 5 volts to 12 volts. It looks like in the video,
Okay.
or maybe
Mm-hmm.
it modulates from 12 volts to 5 volts. I'm not sure.
Yeah. So it's a power amplifier.
Essentially, I think so.
Mm-hmm. And
And it
what
doesn't
about
have to be
the?
the L293D. You can get like this other drivers that you can get.
Yeah. Okay. I'll see which ones are compatible, most compatible with the Arduino. Which
Yeah.
I mean, they all should be, but seeing which pairs best with it. Mm-hmm. What about the 7805, the LM?
Uh, you don't need that.
Nope. All right. Let's see here. Let's see. AC components. Let's see. ADL293DN.
Trying to find better ones.
Yeah. Driver.
Yeah, like the sound just won't be loud enough if you just use the Arduino without the that chip.
Okay. Yeah. Let's see. Mhm. So let's see. What I'm looking at is that most of these speakers and transistors are like 40 kilohertz. I think that's 40 kilohertz.
Mhm.
40 kilohertz. Let's see. I wonder if that would need a certain voltage to maximize. Because you can turn down like the voltage and it turns down
Mhm.
the audio level. I wonder if that affects like the hertz at all.
Should be. I think they're independent, so
Independent?
you should be
Okay.
fine. Yeah.
Yeah. Perfect.
Um. Yeah. So I'm looking at other chips. It says the chip they're using is a bit outdated.
Hmm.
Um. Other chips you might want to look at if you want to write this down somewhere.
Yeah,
You can
writing
look at
a bunch of stuff down. Yeah,
a MOFset half bridge.
Moffset half bridge.
Yeah.
Moth like the animal, right?
No, MOFSET.
Moffset. Moffset.
MOFSET. Yeah.
Yeah, Moffset.
You're gonna
Okay.
get very familiar with MOFSETs. They're a type of
Mhm.
semiconductor.
Oh, okay.
MOFSET half bridge or and a gate driver IC.
Yeah. Let's see. Gate, gate driver. ICE, right?
I just IC.
IC. Okay. I see. Hmm. Let's see. Okay. So those on top of an Arduino. And of
Hmm.
course, like a breadboard. Breadboard.
Yeah, and by the way, those two go together. They're not like two separate parts. It's not like either the offset half bridge or the gate driver. You need like both together to work.
Okay. You need both together
Um,
to work. All right.
yeah,
Perfect. Perfect. Let's see. Breadboard, wires. Are there different kinds of wires I should know about? Like, I know copper wires are a thing, but I know they're not standard anymore.
yeah. Just no, just buy like literally standard wire. Like I'm not even sure what they use. They probably use aluminum wire now, and you can
Hmm.
just get like a ton for absolutely nothing.
Nice.
Um, yeah. One thing you want to look at is like what gauge of wire you use. Which is like the thick, like the diameter.
Oh, okay. Does that affect like current, voltage, or any of that, or?
No, it's just like if you need to plug it into things,
Oh, okay.
but it should be okay.
Hmm.
Yeah,
Okay.
I would just get like a standard, like a 20 gauge or something,
Yeah.
24 gauge, like what I mean, anything doesn't really matter. You
Hmm.
want something not too big and not too small. Have you stripped wires before?
Have I have I what?
Strip,
My bad. Oh,
have you
stripped
stripped?
wires?
Yeah.
Yeah, I've stripped wires before.
Okay, good. Um, yeah, so I would get the stuff and then like start messing around with it. I think that'll be best.
Hmm.
Don't order any microchips yet. Just get like the basic stuff you'll for sure need, and then
Hmm.
the Arduino, and then we can start playing around with that before we start getting into like chips and stuff. Because we will need chips eventually, but I wouldn't get them right this instant unless you're sure
Yeah.
or
Yeah.
they're cheap.
Okay. Hmm. So let's see. Guess I'll start off with the breadboard wires and Arduino. Well, the kits, of course.
Uh-huh.
Let's see. Breadboard wires. Arduino. All right. So let's see here. All right. And I might as well just start off by getting the speakers as well.
Yeah, you
Yeah,
still
let's
definitely
see.
need those.
Hmm. See the amount. Let's see. He has like 30 something speakers on here. So I guess I'll just start off with half of those. So about 15, um, let's see, 40 kilohertz speakers.
Yeah, you also don't have to start with 15. You can just start with like one and getting one to work, and then
Yeah.
scale it because it's pretty easy to scale.
Okay. Yeah.
Let me see. Bum, bum, bum.
Yeah. Guess I'll also just like practice making circuit diagrams too.
Yeah, but you don't really need to practice. I think building circuits is a much more valuable skill than being able to do circuit diagrams.
Okay.
Um, Circuit diagrams is more just like communicating with people and like keeping track of what you're doing.
Mhm. All right.
Um,
Understood.
but it's an important skill. Like you should do a circuit diagram once you've built a circuit that works. Like
Mhm.
don't draw a circuit diagram, then build a circuit of it. Mess around with the wires, mess around with it in person, and then once you get it working, then make a circuit diagram of your final version.
Okay. Yeah, makes
Um,
sense.
because I mean it's not worth it if not.
Mhm.
Let's
All right.
see. And do you think that the speakers you sent are already sufficiently unidirectional, or do you think you're gonna have to add
Mhm.
component parts,
Let's
build
see.
something to make them more unidirectional?
Mhm. I'm not quite sure yet. I'm probably going to know once I receive them. But if they're sufficiently unidirectional, then hey, the casing could just amplify whatever's already there.
Hmm.
Hmm. Let's see. The idea is to just like make it slightly better, which I think is just the basis of most engineering projects. See how it can make something slightly better.
Yeah.
Hmm.
Okay, so it looks like the ones that you sent me are conical, and they're not quite a beam, but like they're better than like a normal speaker. So you can
Yeah.
start with these,
Mhm.
and then let's see. Yes, these are good for prototyping. For a final
Mhm.
product, you probably wouldn't want to use these, but
Mhm. Yeah, they're good to start off then.
yeah, and you would also want to use an array, obviously,
In
like you
array.
said. Yeah,
Yeah.
like multiple, not just one.
Yeah. All of these. All right. Perfect. Perfect. Let's see an array of these. Let's see. Yeah. So we'll start off with prototyping with a breadboard, wires, Arduino. See how else I could program this. Mhm.
Yeah,
Because what I imagine would probably take the most time out of me is seeing what I can do with the Arduino. Mhm.
yes, I agree. Getting familiar with Arduino is gonna take some time, but you'll pick it up pretty quick, I think.
Okay, sounds good. Mhm. Yeah, because I heard it has this its own like coding, not software, but platform. You know how a lot of people use like Windows PowerShell or Microsoft Code Studio? They have like their own Arduino board.
Ah, okay.
Yeah, to work off of. I don't imagine it's that much different from like PowerShell, but it's going to be unique using it. Hmm. Yeah. Let's see. What have you coded with like a Raspberry Pi?
Um, just like pretty simple stuff for class, like
Hmm.
playing like sounds, like playing music, getting like lights to blink, like timers, like a thing to count up from count down from like 10, um, something like display the time,
Hmm.
like just like simple stuff, like counting in binary with lights.
Hmm.
It's pretty easy to pick up though.
Okay.
Um, you'll be fine.
Yeah. Okay. So let's see. This is how I'm thinking about going about once I get the actual Arduino. I'm going to start off by just connecting it to the speakers and having the speakers work. Then after that, I'm going to see if I can code it to play a specific sound.
Hmm.
Mm. Then we
Yeah.
can work ourselves up with multiple speakers, um, potentiometers, and see how we can build ourselves to the final. I guess you can call it the final first model.
Hmm.
Hmm. Yeah. Okay.
Um, yes. It also looks like the angle of the beam that comes out is roughly proportional to the wavelength decided by the array width.
Oh, okay. Yeah.
So assuming our wavelength is fixed, because we want it to be at 40 kilohertz, so that's like a fixed wavelength,
Hmm.
right? Because like fixed frequency means fixed wavelength too. So the one thing we have control over to make a thinner beam angle is the array width. So it looks like increasing the array width would tighten your beam.
Array with okay. Hmm. Array with. So you mean more speakers would mean like a tighter array?
Yes,
Okay.
which feels counterintuitive, but that's how the physics works out, I believe.
Hey, physics is physics. So
That's true.
uh, 40 kilohertz. Kilohertz wavelength. So speakers. Perfect. Perfect. Okay. All
Yeah.
right. Let's see. I'll order the parts and I'll hopefully have them by next week or the week after. Because I
Hmm.
think I might go to like, because I live pretty close to Dallas, so I can just go there, find an electronics store.
Yep. Yep.
Hmm.
Also going in person is a good idea.
Hmm.
Um, yes. So like the more what's it called speakers you have, the more precise it'll be. Go to the electronics store, get everything you need. I would work on like a just like a brief outline of like kind of how you want to approach this. But yeah,
Hmm.
once you actually get your components and you start building it, then that will be good. So like do you feel like you have a clear grasp on next steps from here?
Yeah. So get the components once they arrive, start playing with the Arduino, seeing how I can connect it to just one speaker at first and how other can react to it. So a
Yeah.
speaker with a resistor, transistor, capacitor, after which then I can start playing with multiple speakers and multiple other components.
Yes.
Hmm.
So get one speaker to be able to play just a sound, then one speaker to play like a melody, a song, whatever,
Hmm.
and then scale it up. And scaling it might be a bit of an issue because you might run into like you might just not have enough power. So that's when you might need to buy the other chip to get more power.
Yeah, yeah.
Slash literally get a bigger battery. Um, so depending, I don't know how much power all these speakers need. So I guess that's something you'll find out when you get them.
Yeah. You're talking about
But
the L293, right? The driver.
yes, yeah,
Yeah.
except probably not that
Mhm.
one because it's a bit dated now. But
Okay. Yeah.
eventually, you when you scale it up, you probably need to get it. But you'll have to scale it up to get that narrow beam.
Yeah.
I would also like in your pitch, I would include like math equations to back it up.
Hmm.
It's like you can say that roughly theta roughly proportional to lambda over d, where theta is the angle, lambda is the wavelength, d is the array width.
Let's see. You said theta is um you said directly or indirectly?
I think it's proportional. I don't know if it's
Proportional. Yeah.
theta is equal to lambda over d, or maybe it's like
Yeah.
yeah, roughly it scales with lambda over d.
Yeah.
Like let
Over
me try and find the exact. Let's see
yeah.
if there's an equation.
Mhm. Let's see.
Oh my gosh. Okay. Yeah, the exact equation is a little complicated.
All right. Let's
It's not
see.
complicated. It's just got like a bunch of like signs and squared terms.
Let's see. Share
Um,
your screen real quick if you can.
yeah, I'll just send you an image in the chat. It'll be easier.
Ah, perfect.
Also, this is just something I found on the internet, so take it with a grain of salt.
Hmm.
I'm more confident with the it scaling with lambda over d.
Okay. You
I
said
will
lamb
invest
or
lambda over d, like it's scaling
lambda?
with a wavelength over d.
Oh, wavelength
Lambda's
over
the
D.
wavelength. Yeah,
Yeah, the Greek symbol for wavelength. Yeah.
yeah. I would take that with a grain of salt. I'll look into it more and see if I can find like a more correct equation rather than just the first thing I found.
Okay. Oh, okay. So this is talking about specific sine pi. So pi distance over wavelength times the sine of pi. Oh, okay. This
Yeah,
is all
d being the array width. D is the array width, not
okay.
distance.
Okay, array width.
Yeah.
Array width. Okay, perfect. Mhm.
I is the far field angular response.
Far field angular response. So
Yeah,
it's
so
not
basically like
yeah.
how wide the angle is,
Okay.
essentially, is what that
Hmm.
means.
Yeah.
So you're looking to minimize this number. Um, mm, mm, mm.
Sine of over array width. This is over 2. Okay, yeah. Thankfully, AP Physics C has lightly trained me for this.
And then
Very lightly.
one other thing you're gonna want to think about is like how you could like next steps once you get a prototype working. Because like
Hmm.
obviously you were talking about like the meta glasses. This right now is like huge. Like it's not huge, but like it's
Yeah.
significantly larger than meta glasses. Like how you could scale this down. Um,
Hmm. Let's see. We can start off by doing traditional headphones and headsets.
yeah, for sure.
Hmm.
That's
Yeah.
that's yeah, that's I think it's a good start.
Mhm. It's
And
not much bigger than them, so I think it's a good place to start looking around it.
but yeah, I totally agree. YouTube is like a good place to start. Like you can find all sorts of great stuff. I'll also ask my roommate because he's actually an electrical engineer. Um,
Hmm.
so he would definitely know better than me. So I'll talk about this with him, see what he thinks.
All right, perfect. Thank
Um,
you.
because he is way more knowledgeable than me in these kinds of things.
Hmm. All right. Okay. Perfect. All right, all right. We got like 2 minutes of the hour left, so I think I can let you go for today. We pretty much covered everything to start off, right? Or is there anything
Uh-huh.
else I should know about?
I think this is a good start. If you ever get stuck, like let me know. Do you have my contact?
I don't think I have your phone number yet. Yeah, let me put
I'll
mine in the chat.
I'll just send you mine.
7, 8, 5, 1.
There you go. Okay, that's mine. If you ever
Yeah.
get stuck, like send me a text, or if you have a quick question.
Yeah.
Um,
Perfect. Perfect.
and I'll probably go pest my roommate and ask him how to fix something because I don't know how, but I might know
Yeah.
how.
Yeah.
But yeah,
Mhm. All right.
YouTube is very good. Lots of good things.
Yeah, I'll look into it. I'll look how we can properly develop a roadmap because that's what I imagine most of engineering is setting up the roadmap and then following through on it.
In theory, honestly, most of it is just like messing around with stuff and trying to debug stuff and get stuff to work. Um,
Yeah, I'd
so,
imagine.
but yeah, it's nice to in theory have a nice roadmap.
Hmm.
But yeah,
Uh,
I think you got a decent roadmap right now. So yeah, just thought I don't know. Good luck. Have fun. Learn something.
yeah,
Don't
yeah.
blow up too many capacitors. Capacitors do blow up. Be careful.
Uh, I'll try my best. All right. Thank you, Jonah. I'll see
All
you
right.
next week.
Have a good one.
You
Bye.
too. See ya.